The AdaBoost algorithm proposed by your friend and Robert Shapiro is one of the most important ensemble methods since it has solid theoretical foundation, very accurate prediction, great simplicity. Shapiro said it needs only just 10 lines of code and wild and successful applications. Let X denotes the instance space, and Y the set of class labels. Assume 1 is equals to the set minus 1 and plus 1, and given a weak or base learning algorithm and a training set. The set of the pair x1, y1, x2, y2, and so on to xm, ym, where xi is in x and yi is in y, where the index I is starting from 1 to 3 until m for both xi and yi. The AdaBoost algorithm works as follows. The input is the dataset D, which is the pairs x1, y1, x2, y2 we just described before until xm, ym, and the base learning algorithm L, and then the number of learning rounds T. These are the input. And what will be the process of the AdaBoost algorithm? The process, first we let assign d1 of I is equals to 1 over m, initialize the weight distribution for all those set. And for t starting from 1 to 3 until t, capital T, we let ht equals to L of d and dt. That is, we try to train a weak learner ht from d, the data set, using distribution dt. Then we let epsilon t equals to the probability of the ht of xi not equals to y, where the probability is assumed that I is approximated by ti. That is to measure the error rate of this hypothesis, the weak learner. Then we assume that alpha t is equals to 1/2 times ln of the term. 1 minus epsilon t divided by epsilon t. We determine the weight of ht. Then we updated dt plus 1 of I, which is equals to dt of I divided by zt times the following options. If ht of xi is equals to yi, then we let it multiply by the exponentials of minus alpha t. However, if ht of xi is not equals to yi, we let dt of I divided by zt times exponentials of alpha t. That is, if we update the distribution where zt is a normalization factor which enables dt plus 1 be a distribution, then we let dt plus 1 of I equals to dt of I times exponentials of minus alpha t times y times ht of xi, then divided by zt. Okay, then this process, we just processed the dataset, the basic learner algorithm, and also we updated the number as the number of learning rounds goes on. Output will be the h of x, which is equals to the sign of sigma, summing for all alpha t times ht of x, where the sigma summation is summing for all the index t starting from 1 to capital T. So first, it assigns equal weights to all the training examples. xi, yi, again, y is taken from the index set of 1 to 3 until m, and let dt denote the distribution of the weights at the tth learning round. From the training set and dt, the algorithm generates a weak or base learner ht, which maps from x to y by calling the base learning algorithm. Then it uses the training examples to test ht, and the weights of the incorrectly classified examples will be increased. Thus, an updated weight distribution, dt plus 1, is obtained. From the training set and dt plus 1, AdaBoost generates another weak learner by calling the base learning algorithm again. Such a process is repeated for t rounds, and the final model is derived by weighted majority voting of the t weak learners, where the weights of the learners are determined during the training process. In practice, the base learning algorithm may be a learning algorithm which can use weighted training examples directly. Otherwise, the weights can be exploited by sampling the training examples according to the weight distribution dt. The pseudocode of AdaBoost is shown just below figure that we have described before. And all these classification algorithms can be implemented on different types of data sets, like data of patients, financial data according to performance. On the basis of the performance of these algorithms can also be used to detect the natural disasters like cloud bursting, earthquake, etc.